Welcome to Math Tutorials. In this video, we are solving every question of the miscellaneous exercise on Chapter 10, Vector Algebra, from the NCERT Mathematics textbook for Class 12, Part 2. The miscellaneous exercise on Chapter 10 has 19 questions across the whole of vector algebra: components and displacement, section formulas, cross-product geometry, inclination proofs, and 4 multiple choice. Here they are. Question 1 of the vector algebra miscellaneous. A unit vector by its angle. Cosine and sine of 30 degrees are its components. Cosine 30 and sine 30. Root 3 over 2 and 1/2. Question 2. The general two-point vector. Differences of coordinates, then the root. Components are the coordinate differences. The magnitude is the root of their squares. Question 3. Two legs of a walk added as vectors. Resolve the slanted leg into east and north parts. West is -4 hat. The second leg is 3 sine 30 east plus 3 cosine 30 north. 3/2 and 3 root 3 over 2. Question 4. Vector addition versus length addition. The triangle inequality is usually strict. Take B as I hat and C as J hat. A is their sum with length root 2, but the lengths add to 2. Not true in general. Equality only for like-directed vectors. Question 5. Scale the diagonal vector to length 1. The base vector has length root 3. Modulus x times root 3 equals 1. X is plus or minus 1 over root 3. Question 6. Resultant first, then scale. The k hats cancel in the sum. The resultant is 3I hat plus j hat with magnitude root 10. Scale by 5 over root 10. Question 7. Assemble the combination, then normalize. Component-wise arithmetic first. The combination is 3I hat minus 3j hat plus 2k hat, magnitude root 22. Divide. Question 8. Proportional joining vectors, then the section ratio. A B against BC. A B is 4, 2, 6 and BC is 6, 3, 9. BC is 3/2 of a B, so the points are collinear. The ratio of B to BC is 2 to 3. B divides a C in ratio 2, 3. Question 9. The external section formula in symbols, then a midpoint check. External 1 to 2. R is 1q minus 2p over 1 minus 2, which is 3a plus 5b. The midpoint of R and Q averages to exactly 2a plus b. P. Verified. Question 10. Diagonal by addition, area by cross product. 2 computations in 1 question. The diagonal is 3 minus 6, 2 with magnitude 7, unit 1/7 of it. The cross of the sides is 22I hat plus 11j hat, magnitude 11 root 5. The area. Question 11. Equal angles force equal cosines. Their squares must sum to 1. With L equal M equal N, 3L squared is 1. Each cosine is plus or minus 1 over root 3. Question 12. Perpendicular to both means parallel to the cross. The dot with C fixes the scale. The cross of A and B is 32, minus 1, minus 14. C dotted with it gives 9. Scale by 15 over 9, 5/3. Question 13. A unit vector condition hiding a quadratic that collapses. Set the dot over the magnitude to 1. The sum is lambda plus 2, 6, minus 2. The dot with the 1's vector is lambda plus 6, and squaring the condition kills the quadratic terms. Expand, 8 lambda equals 8. Question 14. Symmetry made rigorous. Each cosine computes identically. The sum has squared magnitude 3 a squared. Its dot with each vector is a squared. Every cosine is 1 over root 3. Question 15. Pythagoras as an equivalence. The cross term is the whole story. Expanding gives the two squares plus twice the dot. Equality holds exactly when the dot vanishes, which for non-zero vectors means perpendicular. Question 16, multiple choice. When is the dot non-negative? Cosine must be non-negative, endpoints included. The dot is proportional to cosine theta, non-negative on the closed interval 0 to pi over 2. Option B. Question 17, multiple choice. Square the sum of unit vectors. Cosine must be minus 1/2. The squared sum is 2 plus 2 cosine theta, equal to 1 when cosine is minus 1/2. Theta 2 pi over 3. Option D. Question 18, multiple choice. 3 scalar triple products of the axes. One of them carries a minus sign. J cross K is I cross K is minus J, I cross J is K. The sum is 1 minus 1 plus 1, which is 1. Option C. Question 19, the final question of Chapter 10, multiple choice. Cosine magnitude equals sine. Tangent 1, the condition reduces to modulus cosine equals sine, that is tangent theta 1, pi over 4. Option B. That completes the miscellaneous exercise, and with it Chapter 10, Vector Algebra. In the next video, we begin Chapter 11, Three-Dimensional Geometry. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.